So earlier we learned about the fundamental theorem of calculus, and what was that? There was actually two parts to it. So the first or the second part, well, one of the parts is the integral from a to b. We got this lower bound a, upper bound b of little f of x dx is going to equal capital F of b minus capital F of a. So that should seem familiar at this point. Capital F, remember, represents the antiderivative. Well, now we know how to actually find the antiderivative because that's what we did in the past couple sections, right? So that's exactly what we're going to do now. We're going to put it all together. We're going to find the antiderivative and then plug in our bounds. That's basically the idea here. So let's go ahead and start with this one. So we're going to integrate from 5 to 10, 3x plus 3 in respect to x. So when we integrate this, that's going to be 3x squared over 2 plus 3x. And with the definite integral, we don't put the plus c because what we would end up doing is we'd have plus c and then we'd subtract that same exact c, that same exact constant, and it would just disappear anyway. So we don't have to worry about plus c on this. What we are going to do, though, is I'm going to put parentheses around this, and then we're going to put a line here, or they sometimes call it a box, if you can draw a box, and from 5 to 10, that just tells us those are the bounds that we're going to plug in. So once you have taken once you have found the antiderivative, that's when we draw this, and it's just going to represent that we need to plug in the 10 and we need to plug in the 5. We're just going to run it right through this here. So we have capital F is this function here. This is just a reminder that we need to plug in those bounds. So let's go ahead and plug those in. So we'll have 3 times 10 squared divided by 2 plus 3 times 10. So that's for our left bound. Can't even draw parentheses anymore. There we go. And let me just go ahead and I'm going to want to make this a little bit more clear. So I'm going to put a color for this one here. I forgot something. Forgot the 3. So that's going to represent plugging in the 10. So that's representing our upper bound, right? That's the f of 10, f of b. And then minus f of a. So let's do one for the lower bound. So let's make the lower bound. Let's go with green. 3 times 5 squared. So you're just seeing I'm plugging the 5 into the x. Then all you do is just evaluate this. You just simplify. Good old PEMDAS at this point. So we're going to have 10 squared is 100. 300 divided by 2 is 150 plus 30 in this set of parentheses. Minus the other one, we're going to have 75 over 2 plus 15. Great, so we get a fraction. We get to keep our fraction alive here, right? These 2's are looking like z's. I'm trying to go back to that classic 2. It's just really hard for me to break those old habits. You need a little bit more space. These just take up a lot of paper, but they're not bad at all. So that's 180, but I'm going to put it over 2. Might as well. 180 times 2 is 360. Minus, and then over here, this will be 30. So 75 plus 30 is 105 over 2. And then just subtract the 2 of them. I don't even know what that is. 360 minus 105. It's 255. Divided by 2. So same idea for this one. All of these, actually, just the same exact thing over and over again. I'm going to go ahead. Let me do this one here. So we could change the bounds, but algebraically you don't need to. Normally like the lower bound on the bottom, upper bound on the top, right? And the 2 and the 1 is a little mixed up, but I'm going to go ahead. You know what? Actually, because it's a -4, let's go ahead and flip them. It's going to actually make things easier. So that's going to become from 1 to 2. But algebraically, we don't have to worry about this so much. It'll actually self-adjust. And, if I had more time on these videos, I would show you guys. So that's going to equal 4x to the negative 2 divided by negative 2 from 1 to 2. Which that just simplifies, right, to negative 2 over x squared, actually. I'm going to go ahead and put that on the bottom. When we plug it in, it'll be easier that way, from 1 to 2. And so then we'll have negative 2 over 2 squared minus negative 2 over 1 squared. And then that's going to be negative 1/2 plus 2, which is 4 over 2. It's just getting worse. And add those up to get 3 over 2. See if there's anything else to look at. This one, your antiderivative is 4x. Don't overthink it. And then you just plug in your negative 3 and your 5. Pretty simple. And this one's just a bigger polynomial, but still the same thing. You know, I would refer to this one for that example.